Hello and welcome. This is a demonstration of the analytics platform mGuard CompressorWatch and a brief overview of our flagship gateway, mCore SDR. For further detailed information, please check out our website or contact us by email via the contact information at the end of this presentation. On the left is Monico's flagship gateway, mCore SDR, for industrial data acquisition, edge analytics, and industrial protocol translation and conversion. mCore SDR has a small footprint of only 4.5 by 3 by 5.25 inches. It is connected to machines via a wire harness kit, which Monico pre-configures and builds for the specific machine to which it will be connected. On the right are some example dashboards from mGuard CompressorWatch. Before we jump into the demo, I'd like to briefly introduce how data is captured into mGuard CompressorWatch. What is mCore SDR? mCore SDR is a compact and rugged gateway that is designed to collect, translate, and transmit machine data that exists in various industrial protocols for use by other systems. mCore was specifically designed for harsh environments with a Class 1 Division 2 rating commonly found in compressor applications. It is capable of handling extreme dust, water, and temperature environments. All mCores are shipped with a pre-configured software setup, as well as the necessary wiring harness kits for connecting to the appropriate ports on the compressor package. The pre-configured setup saves a considerable amount of time when connecting compressor packages to CompressorWatch. Monico's setup considers the protocols that are required to be captured and converts these protocols into a format for ingestion into the CompressorWatch database. However, mCore is not limited to just communication protocols used by OEMs such as Cat Data Link or J1939. It can also be connected to non-OEM sensors such as flow meters, vibration transmitters, temperature sensors, or pressure transmitters. Although the mCore comes pre-configured right out of the box, access to the mCore is made easy through its browser-based user interface. All data configurations, inbound and outbound, are configurable by the end user via the interface. The interface can be accessed remotely or by connecting directly to the mCore via a laptop to one of the Ethernet connections. The mCore SDR is a powerful device for industrial data capture and can be used both with mGuard CompressorWatch or with other applications that need machine data. For our customers that don't already have an end-to-end solution for managing their equipment health, we offer mGuard CompressorWatch. CompressorWatch is a web-based solution that resides in Microsoft's Azure cloud. It is not necessary for the customer to install any software in their environment to use it. All that is required is a web browser. It uses existing compressor package data to 1. Automatically notify operators of developing failure modes so that corrective action can be taken before an unplanned outage or serious damage occurs. 2. Provide KPIs such as runtime, utilization, reliability, and mean time between outages. 3rd, provide visualization of real-time compressor package data. It is not necessary to install additional sensors or devices on the compressor package with CompressorWatch. However, the size of the dataset can impact on how specific the recommendations are. With CompressorWatch, operators can quickly take advantage of an equipment health management solution without having to develop their own infrastructure of servers, analytics, and subject matter experts. This allows them to enjoy the benefits of a solution much more quickly and at the same time allows them to reserve their financial and human capital for their core business. The core function of CompressorWatch is to identify developing failure modes as soon as possible by continuously analyzing incoming streaming data. The analysis looks for changes in the data that indicate that specific failure modes are developing. The data includes sensor data, derived data, controller commands, equipment states, and OEM alarms. This data is analyzed automatically 24/7 by CompressorWatch. Notifications are automatically sent 24/7 as failure modes are identified. Notifications are sent by email to customer-specified personnel. The notifications identify the asset, failure mode type, time of occurrence, and contain a link to visualize relevant data for obtaining more context. Now let's take a look at a couple of notifications that were automatically created by CompressorWatch. Here you see my inbox with a number of notifications in the left-hand column. I've selected one for unit GC4-1. It's a compressor cylinder number 3 potential compressor valve failure. And it was noted that the discharge temperature of the cylinder increased by 5 degrees over the past 4 hours. Now, that doesn't mean that it gradually increased by 5 degrees over the past 4 hours, but rather there was a sudden increase of 5 degrees and it was persistent for 4 hours. Now, the most likely cause is a compressor valve failure, but there's an outside chance that it was false data created by a failing compressor discharge temperature sensor. So let's take a look at see what was going on by clicking on the link that's provided. And it takes you to the asset, GC4-1. You don't have to hunt for it. And it takes you to a time range in which the notification occurred. So you don't have to hunt for that either. If you go to the bottom right-hand corner of the display, it shows the time and date of the right-hand side of the trend. Then in the middle, it shows that it's 1 day, and this is the default for this particular failure mode. It shows 1 day of previous data, and this would be the end time or the beginning time of the trend. Also, on the display are tables which, for each of the parameters that are displayed, shows you the average, the minimum, the maximum, and range of those values. So, for some easy additional context. Once you have come to this place, there's several different things that you can do. One is you can zoom in and get a little bit a better indication as to what was going on with the temperature rise. We're going back to 1 day's time worth of data. The other thing you can do is show what was happening the week before. Very easy to bring that data in. We'll go back to this particular portion of it, and depending on when you come in, you can also scroll manually like that to see that it is definitely a persistent increase in temperature. And later on, after corrective action was taken to get some insight as to what it was doing, you can go into this lower right-hand corner and enter a specific time to show the data. We're going to May 19th. And this is kind of noisy, so we'll hide this speed display. And now you can see that cylinder number 3 is definitely reduced in temperature. It's below the other temperatures within the trend. Let's take a look at another example of a notification from CompressorWatch. This particular one has to do with engine or with the unit GC3-4, which has a Caterpillar G3600 engine on it. The issue is the engine is being controlled by the choke and not the wastegate. And as an indication that CompressorWatch is a around-the-clock type notification, this one was created at 8 p.m. In this particular case, the engine was operating within its normal load and speed range, but instead of the air-fuel ratio being controlled by the wastegate, it was being controlled by the choke. The wastegate position command had not changed for at least an hour. The most likely cause is a stuck wastegate valve or actuator. And if uncorrected, the engine may have difficulty not only in managing air-fuel ratio, but controlling speed, and eventually could shut down on detonation or excessive fuel correction factor. So let's take a look at the data by clicking on the link. This takes us to an engine control display, and we see that it is for unit GC3-4. This display has parameters, both trends and tables, that show parameters that are used by the engine to manage speed, load, and air-fuel ratio. Before we look at that a little bit further, I want to point out that on this display, we also have engine event diagnostic codes, which are displayed as trends. And you can click on any portion of the trend and see at that particular time what an active code may be. And the nice thing about that is that that cursor is synchronized with all the analog data that's coming in, and which would take you to a period of time where you could see any change in parameters that might explain as to why that particular code was being generated. Now, if we scroll down to the trend that has to do with air management, we can highlight the wastegate position command and see where it went unstable, and then went to a maximum to where it was opening up, trying to reduce the amount of intake manifold air pressure. But being unable to achieve that, it started using the choke to reduce the intake manifold air pressure. We can zoom into that and get more insight as to looking at the instability that occurred in the wastegate prior to not being able to move at all. And we can see what the choke was doing. If we go back up to the alarm trend, we would see that there's no active engine codes, meaning that even though the engine was managing itself, it didn't notify the operator that it was having a problem with any of its components. However, CompressorWatch did. Now, once corrective action is taken, we can see what the effect of it might be. So I'm going to go further down in the history to see what was going on with these parameters once the corrective action was taken. And at this point, we could see that the wastegate was modulating as expected, as it was supposed to, and throughout the period, the choke was wide open. Thank you for your time today. For further information on mCore and mGuard compressor watch, please check out our website at www.monicoinc.com, or feel free to reach out and contact us directly at sales@monicoinc.com.